Good day, everyone. My name is TEOH XIU WEN, and today I'll be presenting on the application of a bipolar junction transistor, or BJT, in an ECG amplifier circuit. So, an ECG amplifier circuit is an important biomedical electronic system used to monitor the electrical activity of the heart. In this presentation, I will explain what an ECG is, how an ECG system works, and the basic principle of a BJT transistor. Most importantly, how a BJT is used to amplify ECG signals. What is ECG? ECG stands for electrocardiogram. It is a medical technique used to record the electrical activity generated by the heart during each heartbeat. Every time the heart contracts and relaxes, tiny electrical impulses are produced. These electrical signals travel through the body and can be detected using electrodes placed on the skin. The ECG signal provides valuable information about heart rhythm, heart rate, and possible cardiac abnormalities. Doctors use ECG monitoring to diagnose conditions such as heart attacks and other cardiovascular disease. However, ECG signals are extremely weak. Their amplitude is usually between 0.5 millivolts and 5 millivolts. Because these signals are so small, they cannot be processed directly by electronic devices. Therefore, amplification is necessary before the signal can be displayed, analyzed, or stored. This is where transistor-based amplifier circuits become important. The ECG monitoring system consists of four main stages: electrodes, amplifier, filter, and display. So first, electrodes are attached to the patient's body. These electrodes detect the electrical signals produced by the heart and convert them into electrical voltage. Next, the detect signal are sent to the amplifier stage. Since the ECG signal is very big, the amplifier increases its strength to a level that electronic circuits can be processed more effectively. After amplification, the signal passes through a filter stage. Filters remove unwanted noise and interference. Common sources of noise include electrical equipment, muscle movement, and power line interference from the surrounding environment. Finally, the clean and amplified signal is displayed on a monitor or computer screen as an ECG waveform. Medical professionals can analyze the waveform to assess the patient's heart condition. Among these stages, the amplifier plays a critical role because without amplification, the ECG signal would be too weak to observe accurately. Now, let us discuss the bipolar junction transistor, or BJT. A BJT is a semiconductor device commonly used for amplification and switching applications. There are two main types of BJTs, namely NPN and PNP transistors. A BJT has three terminals: the emitter, the base, and the collector. The emitter supplies charge carriers, the base controls the operation of the transistor, and the collector collects the charge carriers flowing through the device. One important characteristic of a BJT is that a small current applied to the base can control a much larger current flowing between the collector and emitter. This property allows the transistor to function as an amplifier. In biomedical electronics, BJTs are frequently used whenever weak biological signals need to be strengthened or further processing. This slide shows the basic components of a BJT amplifier circuit. The circuit consists of a BJT transistor, several resistors, coupling capacitors, and a power supply. The transistor serves as the main amplifying element. The resistor establish the correct operating condition for the transistor, while the capacitors help pass the desired signal and block unwanted direct current components. A commonly used configuration is the common emitter amplifier. In this configuration, a small ECG signal enters the base terminal of the transistor. The transistor then controls a larger collector current, producing a larger output voltage. As a result, the weak ECG signal becomes significantly stronger while retaining its original waveform characteristics. This amplification process is essential because it allows the tiny electrical signals generated by the heart to become large enough for filtering, processing, and also display. There are several advantages of using BJTs in ECG amplifier circuits. The first advantage is high voltage gain. A very small ECG signal can be amplified into a much larger signal making it easier for electronic systems to detect and analyze. The second advantage is good signal amplification. BJTs can effectively increase the strength of low amplitude biomedical signals while preserving important waveform information. This is critical because doctors rely on accurate ECG waveform for diagnosing. The another advantage is low cost. BJTs are inexpensive electronic components and are widely available in the market. This makes them suitable for cost-effective medical equipment and also educational projects. Next, BJT is a simple circuit design. BJT amplifier circuits require only a small number of supporting components, making them easy to design, construct, and also maintain. Last but not least, BJTs offer reliable operation. They provide stable performance over long periods and can continuously amplify signals without significant degradation. This reliability is important in medical monitoring systems where accurate signal is essential. Let us now examine a practical biomedical application of the BJT amplifier. One common example is the hospital ECG monitor. So when electrodes are attached to a patient, they detect the heart's electrical activity. These signals are then transmitted to the amplifier stage. At this stage, the BJT transistor amplifies the big ECG signals. For example, a signal measuring only a few millivolts can be increased many times in amplitude, making it suitable for further processing. After amplification, filters remove unwanted noise and interference. The resulting signal is then displayed as an ECG waveform on a monitor. Doctors can observe characteristic waveform components such as the P wave, QRS complex, and T wave. These waveform features provide important information regarding heart function and possible abnormalities. Without the amplification provided by the BJT, the ECG signals would be too vague for accurate observation and diagnosis. Therefore, the BJT plays a crucial role in ensuring that ECG monitoring systems operate efficiently. Now, let us compare BJTs and MOSFETs. A BJT is a current control device. This means a small base current controls a larger collector current. In contrast, a MOSFET is a voltage control device. It requires very little input current and therefore generally consumes less power. BJTs are known for providing high gain, making them very effective for amplification applications. MOSFETs, on the other hand, has very high input impedance and are commonly used in modern integrated circuits. Although MOSFET are popular in many contemporary electronic systems, BJTs remain valuable because they offer strong amplification performance and relatively simple circuit implementation. The choice between BJT and MOSFET depends on the requirements of the specific biomedical application. In conclusion, ECG monitoring is one of the most important applications in biomedical electronics. Since ECG signals are naturally very big, amplification is required before they can be analyzed or displayed. The bipolar junction transistor serves as an effective amplifier by increasing the amplitude of these weak biological signals. As discussed throughout this presentation, BJTs provide high voltage gain, good signal amplification, low cost, simple circuit design, and reliable operation. By amplifying ECG signals, BJTs help improve signal quality and monitoring accuracy, allowing healthcare professionals to assess heart activity more effectively. Therefore, BJTs continue to play an important role in biomedical electronic systems and medical monitoring devices. That's all for my presentation. Thank you for your attention.